All right, problem number 18. So here we have a 7-mark problem. It says in triangle PQR. Let's sketch PQR quick. Here's P and Q and R. Oops. I wanted to flip that around. Hold on a second. How about P and Q and R? Cool. So that makes that angle Q, which is 30 degrees. We got PQ, which is 6, and we got PR, which is K. All right, in this case, K is going to equal 4. It says find the two possible values of QR. Now you might see that this is an ambiguous case where K equals 4 could also signify the second triangle. So instead of this side here being there, we could swing it over this way, and it could be there. So there's two different triangles that could be formed out of these side lengths. So what I'm going to do is I'm going to use the law of cosines in order to determine the values for QR. So what I'm going to do is I'm going to use the law of cosines, which is c squared. So I'm going to go 4 squared is equal to a squared plus b squared. So the two sides sandwiching the angle we know. Okay, so the one side that I do know is 6, and QR I don't know. That'll be minus, so a squared plus b squared minus 2ab cosine of the angle between. All right, I'm going to go off camera for a second, simplify a few things, and come back and talk you through it. All right, so I took 4 squared, it got 16. 6 squared got 36, left QR squared. Combine the 6 and the 2 to make 12 by multiplication. Cosine of 30 is root 3 over 2. Now, I subtracted the 16 over from the 36, got 20. You see that here. I brought the QR squared out here, and I reduced this 12 and 2 and multiplied that 6 by root 3 and got said thing here. Now, clearly, this is a quadratic, so I can use the quadratic formula. I don't know if I could factor that, and I don't really want to try, but I know then that QR would be equal the opposite of b, so 6 root 3 plus or minus the square root b squared. So that's going to be 108, right? I'd square 6 root 3. That's going to equal 36 times 3, which should be 108, minus 4 times a, so 4 times 1 times 20, which would be 80, all over 2a, which would be 2. So QR could either be 3 root 3 plus, what's 28? Let's see, root 28 over 2 is the same as 2 root 7 over 2, so root 7. So either QR could be that, or QR could be 3 root 3 minus root 7. Awesome. Kind of awkward, but clearly that's interesting use of law of cosines in that case. I'm sure there's another way to do that problem, but that's the way that came to my mind initially. Okay, so part B, 3 marks. Determine the value for K for which the conditions above define a unique triangle. So in this case, if K equals 4, we would not have a unique triangle because there's 2 possible lengths for QR. Now, one quick way that I can identify is if PR, okay, or if K is greater than 6. So I've got a length of 6 here. I've got QR here. If this length here is greater than 6, it's 6 or more, greater than or equal to 6, I should say. That's kind of, I don't really like the way that turned out over here. Let's clean that up a little bit. Oh boy. There we go. If that length there is greater than or equal to 6, I have a unique triangle, right? But if that length, so you can notice up here in the diagram above, if k falls somewhere in between whatever this height is, whatever this height right here, this red height is, if it falls between that height and 6, so if I can find this value, if it falls between those two values of 6 and that length, it would not be unique. So I want to find this length. So I know that if k is greater than or equal to 6, then I've got a unique triangle. Ooh, wow, I'm good at spelling. Unique triangle. Or if k equals this length. Now I can find that length relatively quickly. Okay, if I got a 6 here, and I got a 30 here, and this is a 90, I can find the value for x. So the cosine, whoops, that's wrong. The sine of 30 equals x over 6. Well, the sine of 30 is 1/2. If that equals x over 6, x must equal 3. So there you have it. Those are your values for k, such that the triangle will be unique and will not be ambiguous, meaning there could be two possible orientations of the triangle. All right, that's 18. Again, as always, let me know if you need any help or maybe a workout plan. Peace.